the KGB's secret weapon that stole the Cold War. Flames licked the curtains of a rented flat in Vienna while a man who wasn't supposed to exist slipped into the alley, cufflink in hand. Inside that cufflink, a microdot, pages shrunk to a grain, decades of programs mapped in specks of silver. The safehouse phone rang until it melted. A double agent didn't show. Somewhere, an air defense upgrade suddenly didn't look so secret. This wasn't a heist pulled off by a gadget. It was a system, patient, disciplined, everywhere at once. From Cambridge to California, Paris embassies to Tokyo trade fairs. To see how it worked, we go back to a campus tea room. The recruitment machine, Cambridge to cover names. Cambridge, early 1930s. Teacups rattled under the talk of fascism abroad and privilege at home. 5 young men, brilliant, angry, convinced they saw history's hinge, drifted from debate halls into quiet commitments. Kim Philby, Guy Burgess, Donald MacLean, Anthony Blunt, and John Cairncross didn't just become spies, they became a blueprint. The KGB learned something crucial. Elites are pipelines, not in points. If you want tomorrow's secrets, recruit the people who will sit near them 10 years from now. The doctrine hardened in Moscow, work the pipeline. Universities weren't just campuses, they were staging grounds. Ministries were feeder clubs. Industry was a waiting room. Diaspora networks, Polish, Baltic, Jewish, Armenian communities scattered by war and revolution, could be both cover and access. The lesson landed in training schools and field directives. Don't chase titles, chase trajectories. Tradecraft wrapped around that doctrine like a scaffold. Cutouts, intermediaries who kept sources from ever seeing a handler. Brush passes, a folded newspaper exchanged at a bus stop as 2 strangers argued over who had the right-of-way. Dead drops in park fences, chalk marks, hollow trees, magnetic tins under a bridge girder. Microdots reduced manuals to pinpricks glued behind a postage stamp. And backbone networks operated by illegals, officers living under deep cover without diplomatic immunity, backstopped by forged legends and quiet jobs. Talent spotting became a profession. Look for students who read beyond the syllabus, who travel, who write letters that hint at frustration with their own side. Professors who love to mentor. Grad programs where lab keys open not just doors but servers. Exchange scholars who could be cultivated at conferences and eased into material by friends who always seemed helpful. The best targets weren't the loud ideologues. They were the competent ones with reasons to belong and reasons to resent. In London, that meant clerks with codebooks and counsellors with access to diplomatic pouches. The Cambridge men rose, and with each rise, files opened. Burgess carried gossip like a weapon. MacLean handled American relations and drank too much, his bag sometimes heavier than it should have been. Philby learned how to live double, and he learned patience. That was the point. Years passed. Then the vaults cracked. Meanwhile, the KGB refined the idea of access nodes. Why fight for a general when a secretary typed his memos? Why chase a defense minister when a technician wired his phones? Code clerks, cipher techs, systems administrators, before the term existed, were gold. They sat where the streams converged. They had passwords, schedules, and habits. Recruit one and you gained a map. Here, where it got practical. A cultural attaché hosted salons that felt bohemian, not political. A student activist was introduced to a journalist who knew everyone and asked nothing. An engineer got consulting work through a front company that paid on time and seemed connected. Those invitations were assessments. How did they handle flattery, risk, attention? A small favor led to a minor infraction. Then came a request cloaked as solidarity. Share harmless material to help the anti-fascist cause, the peace cause, the cause of equality. The first delivery felt righteous. The 5th felt binding. Tradecraft insulated each step. A source never met the controller's controller. A handler rotated cities. A courier knew only the park bench and the time. Signals were banal. A torn theater stub pinned to a notice board meant shift the drop. A chalk cross below the 3rd brick meant abort. When surveillance tightened, communication moved to letters with invisible ink on the margins of order forms, or microfilm tucked inside a cufflink that would survive a pat-down. The system didn't just find people, it grew them. Mentors groomed recruits, refined their cover stories, game-planned their careers. A promising code clerk got nudged toward a promotion. An analyst received a quiet recommendation to a sensitive desk. A lab assistant was guided to a project with interesting procurement. The KGB called it cultivation. Corporations would later call it career development. The difference was the end user. Ideology powered the early model. The Cambridge Five believed capitalism was a sickness that needed a cure. War and depression gave those beliefs teeth. But Moscow learned to bank on broader motives. Money mattered. Recognition mattered. Revenge mattered. An overlooked engineer could be told his genius would finally be seen. A junior secretary, constantly dismissed, could be told she was essential. And yes, some just liked the chess match, the feeling of being inside the secret world. The payoff came slowly, then suddenly. One recruitment led to a telephone list. The list led to a calendar. The calendar identified a weekly bag run from a ministry to an embassy. The bag run revealed a gap in coverage on Tuesdays. Insert a courier there, fast hands, steady nerves, and a stream of film started going home. Parallel to this, illegals built lives that looked ordinary. A couple ran a small import shop. Their kid went to local schools. The ledger books balanced. Meanwhile, trade fairs were their battlefield. Scientific exchanges were their marketplaces. They collected brochures, yes, but they also collected people. Engineers who hated export controls, scientists who hated bureaucracy, administrators who hated being ignored. Front companies ordered machine tools that skirted COCOM rules. If customs asked questions, someone at a commercial office smoothed it over. The KGB turned embassies into both shields and magnets. Official cover officers took meetings that sounded like cultural chats and ended with recommendations. Meanwhile, across town, the real work happened in apartments with heavy drapes and film drying lines. Illegal residencies shared nothing with official stations except a goal: feed the pipeline and protect it. What nobody outside the circle saw was the file discipline. Each source became a case number with a life cycle: recruitment, development, exploitation, protection. Validation teams cross-checked the material against other streams: signals intercepts, press reports, other human sources. If a piece of data appeared in two places, it gained weight. If it created a third opportunity, say a procurement vulnerability, it triggered a new operation. Tradecraft wasn't romance, it was logistics. Two micro stories. A code clerk in Whitehall took work home once just to catch up. He was followed to a quiet pub by a man who didn't drink. Weeks later, the clerk met a union representative who helped with a small problem. Papers moved. Years after, NATO cables mirrored themselves in Moscow. Another. A technician in a US defense contractor's office got a congratulatory note for an award he never applied for, then a scholarship for his kid. The scholarship came from a foundation that existed mainly on letterhead. Gratitude turned into access. Access turned into files. Files turned into a steady burn. The Cambridge model proved one more thing: protection mattered as much as penetration. When Burgess and McLean fled in 1951, they blew open the risk of elite infiltration. London reeled. Washington seethed. Moscow adjusted. More cutouts, tighter compartments, longer dormancy periods. If a source got spooked, he went quiet for a year. If a handler got burned, the line went dark, not dead. Patience was policy. Meanwhile, across the Atlantic, a different door opened. Ideology would still matter, but so would proximity to the most guarded project on Earth. The KGB didn't need a general or a minister. They needed a physicist who believed the bomb had to be shared, and a family network that could carry drawings through kitchens and tenements. The pipeline pointed to New Mexico. The system was ready to harvest. Stealing the bomb, Fuchs, Rosenbergs, and the Manhattan League. The stakes were simple and brutal. If the United States kept a nuclear monopoly, every Soviet war plan got smaller. If Moscow caught up, the balance changed overnight. The Manhattan Project buried its work under layers of fences, codenames, and compartmentalization. One breach wouldn't just leak ideas, it could end exclusivity. That's where a quiet, precise mind named Klaus Fuchs stepped into the pipeline. Fuchs wasn't a thrill seeker. He was a German-born physicist who fled the Nazis, worked in Britain, and carried a belief that no single power should hold the atom alone. Ideology mattered to him, but so did a specific fear that secret weapons would lock in tyranny. When he reached Los Alamos in 1944 via the British Tube Alloys program, he joined implosion calculations under Robert Oppenheimer's broad umbrella. His access wasn't universal, but it touched the most sensitive: the design geometry, tamper materials, neutron initiators, the timing puzzle that turned a sphere into a sun. The courier chain that connected his desk to Moscow was classic NKVD KGB craft. Fuchs met a cutout in Albuquerque and Santa Fe, curbside conversations, long desert walks, notes committed to memory and copied by hand at night. In Santa Fe, Harry Gold, codenamed Gus, became the relay. There were no cameras in the lab, no convenient microfilm stands. There were notebooks, sketches, and equations reduced to tight script that fit a jacket lining. Gold passed the packages to a higher handler who moved them along the Soviet network through New York. Each link knew as little as possible about the others. If one snapped, the chain wouldn't break completely. What Fuchs delivered wasn't just how to build a bomb. It was the method. He described the implosion lens system that solved the plutonium problem, the use of explosive lenses to drive symmetrical compression, the function of the polonium-beryllium initiator that kicked neutrons at the critical instant. He relayed bomb assembly dimensions, the shift from gun type to implosion, and the flow of the Los Alamos problem-solving culture. Who did what, how fast they moved, where bottlenecks lived. That kind of granularity turned Soviet guesses into engineering schedules. Meanwhile, in New York, a different network worked from kitchens and factories. Julius Rosenberg, an engineer at the Army Signal Corps labs until his dismissal, believed the Soviet Union deserved parity and that fascism hadn't disappeared with VE Day. He wasn't near the bomb, but he knew people who were. He recruited his brother-in-law, David Greenglass, a machinist assigned to Los Alamos. Greenglass drew sketches on onion skin paper at his kitchen table, demountable segments, lens assemblies, mold designs for explosive charges, and passed them through Julius's cutouts. His wife Ethel typed the notes, fixing them into neat pages that handlers could photograph. Codenames stitched the picture. Fuchs as Charles, then Rest. Julius as Antenna, then Liberal. Ethel seen in traffic as wife. Harry Gold as Gus. The KGB residentiaries in New York and Mexico City coordinating pickups and exfil routes. Meetings followed protocols, prearranged street corners, identifying phrases like, "I come from Mr. Raymond," countersons like, "I hear the weather in the east is good." Cash changed hands, modest amounts, enough to prove seriousness, but not enough to flash. A missed signal triggered a fallback date. A shadow on the sidewalk aborted a pickup. Were the Rosenbergs decisive to the Soviet bomb? Historians argue. The consensus: Fuchs was the crown jewel. Rosenberg's ring added valuable industrial and radar information, and Greenglass's implosion sketches had confirmatory value. The network's strength was in redundancy. What one source delivered, another corroborated. Where one drawing was crude, an equation from Fuchs made it precise. Moscow Center's analysts sifted it all, separated noise from precision, and sent tasks back down the line. Clarify the initiator, confirm tamper materials, identify machining tolerances. While all this moved underfoot, the Manhattan Project fired its first proof. Trinity lit the Jornada del Muerto desert in July 1945. By then, Moscow wasn't blind. It took 4 years of labor, scarcity, and ruthlessness to turn stolen insight into a weapon. In August 1949, at Semipalatinsk, the Soviets detonated RDS-1, Joe 1 in American code. Seismographs in Alaska and Japan trembled. Air sampling sniffed isotopes that matched a plutonium implosion, device eerily similar in concept to the Fat Man design. US intelligence first guessed an inside leak because the signature looked familiar. They weren't wrong about the resemblance. They were wrong about the simplicity of the theft. Impact came fast. Washington's assumption of a decade-long lead evaporated. Strategic Air Command, built around uncontested delivery, now faced an adversary that could build, then scale. The US accelerated the hydrogen bomb program and hardened bases. Contingency plans multiplied. Mutual vulnerability began to write itself into doctrine. Mutual assured destruction wasn't a philosophy class thought experiment. It was a planning baseline forced by physics and espionage. The fallout landed on people too. In 1950, British interrogation and the Venona decrypts partial reads of wartime Soviet cables helped break Fuchs. He confessed, carefully, protecting others, and served 9 years in Britain before leaving for East Germany. Harry Gold's arrest cracked the chain to Greenglass. The Rosenbergs went on trial in 1951. It was a fevered courtroom. Cold War paranoia, prosecutorial zeal, and genuine secrets mixed into a moral panic. Greenglass testified against his sister and brother-in-law to save his wife. Julius and Ethel were executed in 1953. Later evidence suggested Ethel's role was limited to typing and that Julius ran multiple industrial sources. Either way, the state made an example. Inside the KGB, the lesson wasn't just victory, it was process. Line chiefs wrote that access plus discipline equals time saved. They noted how compartmentalization at Los Alamos failed at the edges. Machine shops, drafting rooms, procurement queues, where human beings carried work between silos. They captured a doctrine, mapped the workflow, not the org chart. If a project had a bottleneck, recruit around it. If a courier got burned, rebuild the route, not the source. On the American side, paranoia became policy. Security clearances tightened. Background checks dug deeper. Scientists felt watched, and some left government labs for universities, slowing certain programs and shifting where innovation happened. Venona continued quietly, feeding leads without publicly revealing its existence. It wouldn't be declassified until the 1990s, but its shadows fell across arrests and suspicions for decades. Here's a micro moment. A Los Alamos machinist's badge swiped an extra half-hour past midnight. The log kicked a question 2 days later. A supervisor shrugged, deadline pressure. Across the country, a handler waiting near a phone booth in the Bronx scratched a matchbook twice, the signal to abort. Another, a scientist in a boarding house wrote a letter to a cousin in Philadelphia with a curious excess of punctuation. Under a simple heat lamp, the margin came alive with numbers. The Soviets didn't simply copy blueprints. They adapted to the metal, the tools, the workforce they had. That meant delays, improvisations, and sometimes dangerous shortcuts. But the arc bent their way because the starting line moved closer. An implosion lens that took Los Alamos a year to perfect could be attempted in months because the end goal was known. The crash program's calendar shrank, and with it, the West's margin for error. With the nuclear gap closed, the hunt shifted. Atoms were only half the weapon. Guidance systems, delivery vehicles, re-entry physics, radar fusing, these became the new secrets worth a life. And the system that carried equations out of New Mexico was ready to move blueprints out of factories, specs out of labs, and manuals out of Navy vaults. The pipeline turned toward missiles. Penkovsky's files, and the missiles that lied. The crisis window was measured in minutes. If Moscow moved rockets to Cuba and Washington guessed wrong about range or readiness, the next sound could be sirens. What the West needed wasn't courage, it was clarity. A GRU colonel named Oleg Penkovsky offered it, if they could keep him alive long enough to listen. Penkovsky wasn't a drifter. He was born into the Soviet system, fought in the war, rose through artillery and staff posts, and landed in the GRU's foreign military intelligence orbit. Ambition cut both ways. He wanted rank he wasn't getting and respect he didn't feel. He watched party favorites leapfrog him and decided he'd make himself indispensable somewhere else. In April 1961, he pushed a package toward the West through a British businessman in Moscow, Greville Wynne. Inside were photographs, notes, and a proposition. He could deliver the Soviet military from the inside. The stakes were immediate. American U-2 flights could see missile shapes, but silhouettes didn't tell truth from theater. Soviet briefings boasted capabilities that pushed US planners to worst-case assumptions. Penkovsky's access cut into that fog. He got his hands on technical manuals and training materials for the R-12 Divina NATO, SS-4, and R-14 Chusovair, SS-5, medium and intermediate-range ballistic missiles, plus notes on the R-7 and R-9 ICBM families. He photographed them with a Minox rig at night in his apartment and office, laying manuals on a board, clicking fast, repacking before dawn. He passed film through dead drops in Moscow, packages tucked behind loose bricks near the Kutuzovsky Prospect, hidden under park benches, dropped in the shadows of trolley stops. Signals were simple. A chalk mark on a lamppost meant a package was ready. A matchbox in a windowsill meant abort. Diplomatic pouches moved the film out through the British embassy and occasionally the American one. In London and Langley, analysts pored over thousands of pages and strips, cross-referencing with signals intercepts and satellite photography just coming online. What he handed over was technical gold. The manuals spelled out the fuel properties, refueling times, and launch preparation sequences for Soviet missiles. The R-12, road-transportable but site-fixed, needed hours to fuel with nitric acid oxidizer and kerosene, dangerous fluids that forced cautious procedures. The photographs showed pad layouts, checklists, and crew drills. He revealed that Soviet warheads were heavier than Western estimates, which meant their claimed ranges were often optimistic press, not planning reality. He mapped order of battle, which units had which rockets, where they trained, how many launchers were actually operational versus for show. He also delivered doctrine. Briefing books and lecture notes showed how Soviet planners thought about salvo size, reloading, decoys, and command authority. He detailed the role of maskirovka, deception, inside missile deployments, and where it tended to fail under time pressure. He identified that the true ICBM force was smaller and less ready than propaganda implied. On paper, the Soviet strategic rocket forces looked imposing. In Penkovsky's pages, they looked young, brittle, and slower to launch than the West feared. Meanwhile, tradecraft pressed against risk. Penkovsky met case officers and technical teams during trips to London and Paris, where safe flats turned into marathon photography sessions. He memorized questions from analysts. What's the fuel load time? What's the erect-to-fire sequence? And went back to Moscow to pull the next ring of documents. He was taught emergency codes, exfiltration notions that were more hope than plan, and the discipline to stop if suspicion rose. But he craved pace. He wanted to matter in real time. Then came October 1962. U-2 images of Cuba showed MRBM sites under construction. Washington needed to know how long before those tubes could throw fire. Penkovsky's manuals answered. From pad completion to operational readiness wasn't hours. It was days if undisturbed, with fueling windows and crew drills that couldn't be rushed without risk. That knowledge let Kennedy draw a line, a naval quarantine, and buy time without assuming missiles were instantly ready. It underwrote the calculus. The US could pressure without triggering a launch on hair-trigger assumptions. Here's where the missiles lied. Soviet public claims, and more importantly, internal bluffing up the chain, had inflated readiness and numbers. Penkovsky's material exposed the gap between parade strength and field reality. It didn't make the threat small, it made it specific. The so-called missile gap that haunted US politics in 196 tilted the other way in his pages. Moscow had fewer ready ICBMs than advertised and depended on slower, riskier MRBMs for regional leverage. That gave Washington a ladder to climb down without surrendering. Meanwhile, something else was happening. KGB counterintelligence, already rattled by earlier leaks, turned inward. Surveillance in Moscow thickened. A courier missed a signal. A watcher noticed a pattern near a drop site. Penkovsky's hunger to produce never quite matched the safety curves. In October, as the Cuban crisis peaked, the KGB moved. Accounts differ on the trigger. A tail picked up, a compromised line, or a betrayal. But the end was the same. Penkovsky was arrested. Wynne was grabbed on a trip. The line went dark. The backlash was brutal. Penkovsky was tried in secret, filmed to set an example, and executed, official accounts say by shooting, with darker rumors about a crematorium conveyor that fed fear as much as justice. The GRU and KGB tightened controls, rotated officers, and rewrote procedures. Handlers were warned against letting sources set pace. Moscow Center emphasized need to know with fresh teeth. The lesson was don't recruit. It was collect harder, hide better, punish quickly. In the aftermath, Western services absorbed a second lesson. Human sources could calibrate satellites and cameras. A single manual could be worth a squadron of reconnaissance flights if it told you what a photograph couldn't. The sequence, the checklist, the friction. Penkovsky's pages became margin notes on U-2 prints and later Corona satellite film. When analysts saw a fuel truck, they knew the timeline. When they saw crane types, they knew stage assembly was at a specific step. Penkovsky's case also hardened a habit inside the KGB. When you spring a leak, drown it in collection. Plugging holes meant more offensive work to replace compromised lines and diversify access. Directorate T and LineX, focused on technology, took the hint. If the West could read missile manuals, Moscow would read guidance specs, radar fusing documents, and production tolerances from Western factories. The gear that found rockets on an island could itself be mapped and stolen. Micro-stories kept the stakes human. A British case officer in a Moscow stairwell listened to footsteps pause, then continue, and only then slid the film container under a radiator. Across town, Penkovsky rehearsed the angle of a book on a shelf so the camera would catch each paragraph without blurring. In Washington, an analyst who hadn't slept much circled a fuel line diagram and wrote one word in pencil: patience. The Cuban crisis ended without launch. That wasn't Penkovsky's doing alone, but his work let cooler heads argue with data. The price was a life, and a counterintelligence machine that learned to break faster. As Moscow tightened the net, another front quietly bloomed in Paris, where a mid-level engineer with a grudge and a camera would hand over a map of the KGB's shopping list. The farewell dossier, when the West saw the pipeline. Trust collapsed in a Paris living room. Vladimir Vetrov wasn't a legend thief or a master of disguise. He was a mid-level engineer analyst at the KGB's Directorate T, the branch tasked with stealing Western technology. In 1980, under the codename Farewell, he began handing the French DSD thousands of pages, indexes, memos, targeting lists, and internal reports that sketched a single, terrifying picture. The KGB had built a factory for theft, and it ran through the free world. The stakes were everything modern war touched. Microchips, numerical control machine tools, high-strength alloys, CAD software, encryption modules, avionics, submarine quieting. For years, Western governments argued over export licenses while LineX, the operational arm of Directorate T, simply found side doors. Vetrov's materials, eventually totaling around 4,000 pages, turned rumors into a ledger. Not anecdotes, but a pipeline. Who asked for what, which front companies placed orders, which trade shows yielded recruits, and which embassies coordinated the follow-through. Vetrov's motive mixed anger and disillusion. He'd watched colleagues chase perks while sources were treated like parts. Career disappointment sharpened his view. He approached the French because Paris was Washington. He calculated that France could act without triggering the immediate blowback he feared. DSD codenamed him Farewell, kept the circle tiny, and started copying. Photographs of his notes and files moved through quiet hands, then across friendly desks in allied capitals. For the first time, the West saw the architecture, not just the incidents. Identifying LineX turned the abstract into addresses. Directorate T set requirements, everything from 32-bit microprocessor masks to high-precision gyros. And LineX officers in residenturas worldwide worked the list. They built shopping carts with part numbers and performance parameters. They mapped which Western firms made what, which distributors were flexible, which export control officers were overworked. Vetrov's pages named names, cover offices in Paris and Vienna, buyers in Tokyo and Helsinki, shell companies in Switzerland and Hong Kong. Trade missions doubled as procurement cells. Scientific exchanges disguised direct tasking. Attend session B on guard, as approach Dr. X afterward, offer consulting. The Western response started in France. President Mitterrand personally shared the dossier's essence with Ronald Reagan at the 1981 Ottawa summit. Quiet meetings followed. Allies coordinated expulsions of known LineX officers, over 100 in a single wave across Europe and North America. gutting KGB technical operations in months. Export control regimes tightened, COCOM lists expanded, and enforcement got teeth. Licenses faced new scrutiny. End-user certificates drew calls. A machine tool bound for a tractor factory in Eastern Europe now triggered a review against Farewell's lists. Then came the counterpunch: deception. If the pipeline couldn't be closed overnight, it could be salted. Western services worked with industry to seed flawed software, deceptive technical specs, and components engineered to pass initial tests and fail under stress. This wasn't Hollywood sabotage, it was engineering mischief. A numerical control program might introduce microscopic inaccuracies that widened over longer runs. A chip mask might carry a timing edge case. A compressor control system could behave perfectly until a specific load and temperature combination. Rare in labs, common in Siberia. One alleged result became legend: the 1982 Trans-Siberian gas pipeline incident. The story, told later by a former National Security Council official, described CIA-seeded defects in SCADA software for pipeline turbines, acquired by the Soviets through LineX months after installation. A cascade control failure sparked an explosion visible from space. Open sources still debate the size and specifics. Satellite imagery and Soviet records don't fully align, but the episode captured the strategy's logic. Let them steal, but make the prize bite. Industry joined the theater. Some firms created export versions with trimmed capabilities that still looked credible on paper. Others quietly cooperated on trapdoor designs embedded in firmware. Testing departments wrote two procedures, one for honest buyers, one for expected thieves. Conferences became stages for near-truths. Papers hinted at breakthroughs while omitting the practical step that made them work. LineX harvested, but now the basket held snakes with apples. Expulsions and traps didn't end the game. The KGB adapted. With embassies thinned and residenturas shaken, illegal networks leaned harder on commercial fronts and third country routes. Orders flowed through intermediaries in Singapore, Dubai, and Latin American ports where export rules were laxer. Student exchanges shifted to sectors with fewer controls. Retired engineers, newly courted as consultants, found themselves training foreign partners for fees that smoothed consciences. Directorate T rebalanced collection priorities towards software and process knowledge. Things harder to sabotage with a single planted flaw and harder to police at customs. Micro-stories carried the stress. A French case officer opened a metal bread box in Farewell's apartment and saw index cards lined like ammunition, project codes, target firms, country flags. In Washington, a Commerce Department analyst, eyes red, traced a Hong Kong importer back to a mailbox in Geneva that matched a name on Vetrov's list. In a Tokyo hotel, a salesman at a trade fair took a business card with an embassy number on the back, and for the first time, felt the kinship between sales quotas and state power. The Dossier strained alliances too. Some NATO partners bristled at American and French pressure to deny licenses that meant jobs at home. Companies that had played loose with end-user checks suddenly faced headlines and audits. A few governments resented finding their ministries named in Farewell's notes as soft targets. Coordinating a response meant admitting failures. It also meant risking sources. Vetrov's safety sat at the center of every decision. He didn't survive. In 1982, the KGB arrested him. Accounts point to sloppy security around his personal life as a trigger, not necessarily a leak in the DSD chain. He was tried and executed in 1983. Moscow rolled up networks, reassigned officers, and retooled LineX, yet the damage was done. The West had a map. Even better, it had a template for counter-collection. Use visibility to starve, and when you can't starve, feed poison. Impact showed up on factory floors and test stands. Soviet VACs, clones, lagged as mask defects and process gaps multiplied. CNC machines underperformed on tight tolerance parts, forcing rework that ate schedules. Submarine quieting took longer because some imported machine tools weren't as stable as the brochures claimed. Analysts in NATO headquarters started to assume that anything stolen after 1981 might need a question mark. That caution saved money and lives, and created a new problem: sifting true sabotage from normal Soviet industrial drag. Vetrov's legacy wasn't comfort, it was clarity with a warning label. The KGB's pipeline was real, broad, and resilient. Exposing it hurt, but it didn't kill it. The center of gravity simply moved. If Paris was the map, Silicon Valley became the treasure room. Directorate T set its sights on microelectronics, operating systems, and the people who built them. The West, newly alert, would meet theft with stings, but the race would be about speed, not absolutes. Directorate T, how the KGB harvested the West's future. By the early 1980s, warfighting power wasn't just steel and fuel, it was logic gates and code. Directorate T understood that faster than most Soviet ministries. Their mission was simple on paper and sprawling in practice: get the West's future before the West could weaponize it fully. Microelectronics, operating systems, CAD/CAM, advanced materials, anything that made missiles smarter, aircraft stealthier, submarines quieter. The stakes were clear. Whoever won the microchip race set the tempo for everything else. LineX, the operational arm feeding Directorate T, turned trade into targeting. They sent officers to Hanover Mess and Paris Air Show with pocket notebooks and pre-written shopping lists. They moved through IEE conferences and SIGGRAPH gatherings as engineers, trading business cards, asking pointed questions, and learning which booths were fronts for defense-adjacent research. Scientific exchanges looked like prestige. In practice, they were reconnaissance. A visiting fellow toured a fab cleanroom and lingered at the photoresist station. A delegation asked for training on numerical control systems and recorded the keystrokes that mattered. Front companies gave this reach hands and bank accounts. In Vienna, a precision tools importer ordered 5-axis mills destined for a tractor plant. They took a detour through a bonded warehouse and a Baltic port. In Singapore, a firm with 2 employees suddenly had the capital to buy wafer steppers. Hong Kong traders inked contracts for TTL chips by the pallet, citing consumer electronics demand. The paperwork passed first glance, the quantities didn't. When customs tightened, orders split into lots small enough to vanish inside normal commerce. Illegals filled the gaps that diplomatic cover couldn't. Deep cover officers built lives around plausible tech roles: systems analyst, quality inspector, sales engineer. They rented beige office parks, paid taxes, and joined local professional societies. They weren't recruiting generals, they were recruiting product managers, test engineers, and field application specialists, the hands at the switch. One illegal lived for years as a rep selling oscilloscopes. He knew the customers who pushed bandwidth specs and which labs ordered RF gear on rush. That map mattered more than any brochure. Case studies tell the shape of it. Take the VAX. DEC's 32-bit VAX 11 system was a workhorse for engineering and classified modeling. The Soviets wanted not just the hardware, but the ecosystem, compiler behavior, OS quirks, the way engineers used VMS for batch jobs. Directorate T tasked teams to acquire boards and microcode, then mirror the architecture. The result, the SM-EVM line, wasn't a perfect twin, but it put Soviet institutes on a path to run Western software ports and train programmers on comparable abstractions. Every month shaved off that gap was a win across guidance and simulation. TTL logic, 740 series chips, looked humble, but it was the Lego of control systems. LineX officers didn't just buy finished chips, they chased mask sets and process notes. They orchestrated buys of iron implanters and diffusion furnaces through layers of fronts, then flew in consultants to tune yields. A single hint about dopant profiles could turn a 40% yield disaster into a 70% workable line, which meant radar sets and fly-by-wire modules came off benches faster. Numerical control was where metal met math. High-speed milling with tight tolerances is what turns turbine blade designs into parts that don't shatter at 30,000 RPM. Directorate T's lists prioritized CNC controls, servo drives, and the software that scheduled toolpaths. The Toshiba-Kongsberg scandal, sale of multi-axis machine tools and control systems that helped quiet Soviet submarine propellers, wasn't an accident. It was a campaign. LineX mapped which vendors were hungry, which governments were lax, and which specs mattered. Vibration damping, spindle stability, backlash compensation. The deal got done because money wanted to move and export reviewers lacked context. The impact was operational. Soviet boats got harder to hear. The West spent to catch up. Materials science bridged into stealth. You can't steal stealth in one folder, but you can collect recipes. RAM coatings that swallow radar energy at specific frequencies, polymer matrices that dampen vibrations, honeycomb structures that hold shape without weight. Directorate T sought vacuum bagging techniques and cure cycles, adhesive chemistries and surface prep methods, the boring steps that make a lab formula into a factory product. Engineers at Western suppliers got calls for joint research or licensing talks. Some said no. Some said yes for a consultancy that felt like easy money. Human motives didn't change. Some recruits wanted cash. Others wanted credit, the feeling that their ideas mattered somewhere. Export control regimes often made mid-level engineers feel like villains for building good tools. LineX handlers leaned into that resentment. They praised competence, sped up expense reimbursements, remembered spouses' names, and solved little problems. An immigration snag, a hospital bill. The recruitment pitch wasn't ideology. It was respect packaged as professional opportunity. Tradecraft stayed low friction. Rush passes at trade fairs were masked by crowds. A catalogue with a bent corner signaled a meeting point. A sticker on a name badge placed at a certain angle meant switch hotels. Photographs were of whiteboards after a talk, of a demo rig's serial plate, of a training manual left open during coffee. At night, in safe apartments, they shot microfilm of user guides and maintenance docs. The bread and butter pieces that reveal tolerances, failure modes, and service intervals. Validation mattered. Directorate T analysts graded each take, high confidence if it matched independent signals, like a sudden procurement surge from a known contractor, or if it solved an internal pain point. A VAX microcode dump was cross-checked with compiler behavior observed at a university lab. A CNC software copy was test run on a captive machine. If cuts drifted at heat, it failed the trap test. After farewell, paranoia cut both ways. Soviet engineers learned to assume the West might salt the stream. Directorate T built labs to test for poison, stress rigs, long-duration runs, side-channel measurements. The pipeline shaved years off R&D cycles. That didn't mean parity in spirit. It meant parity in snapshots. Soviet air defense networks fielded radars built with better logic and timing once they acquired faster chips. Missile guidance improved as strapped-on INS quality rose with better gyros and math libraries gleaned from Western documentation. Avionics got lighter as materials quality climbed. On paper, these jumps narrowed gaps and scared NATO planners. In practice, the Soviet industrial base often lagged in quality control, so a brilliant design landed in a factory that struggled with uniformity. Directorate T could import the what and often the how, but it couldn't always impose the how well. Micro-stories land the effect. A Silicon Valley engineer passed over for a promotion, found recognition at a think tank that paid him to present on bus arbitration. His slides, innocuous alone, solved a timing bug in a cloned backplane. A Boston area field tech servicing avionics trainers photocopied a maintenance addendum because his handler framed it as a way to help global safety. That addendum listed failure modes and tolerances, gold to anyone building a copy. In Munich, a materials scientist at a conference bar sketched a resin cure schedule on a napkin for a new friend who loved composites. 2 years later, a Soviet airframe part survived a test it used to fail. The West fought back midstream. Export denials forced LineX to route through third countries, adding cost and delay. Firms tightened visitor protocols. Cleanroom tour became windowed lectures. Software keys required dongles and challenge response systems. But speed was the West's double-edged sword. New product cycles meant that even as the Soviets got last year's breakthrough, this year's moved on. The illusion of parity, machines that looked the same on spec sheets, hid a fragility. process integration. Directorate T could deliver parts and papers. Integrating them into doctrine and production still took a culture of iteration the Soviet system resisted. Yet the scoreboard mattered. NATO wargames adjusted assumptions about Soviet radar range, missile set, and submarine detectability because Directorate T kept closing gaps. That forced Western budgets higher, timelines shorter, and secrecy tighter. It made mistakes more expensive, and it set up the next battlefield because hardware meant little if you couldn't keep your communications secret and your enemy exposed. The Cold War waited just beyond the next trade fair. The Code Wars, Venona, Walker, and the battle for signals. While hardware flowed through front companies and briefcases, the real prize was the conversation about that hardware. Who reads whose mail decides where ships turn and when missiles arm. The battle over signals ran under everything. Cipher machines on desks, code books in safes, antennas thick with whispers. And early on, the West caught a sliver of light through a crack called Venona. During World War II, US Army cryptanalysts at Arlington Hall started hoarding Soviet diplomatic and intelligence cables encrypted with one-time pads. Those pads should have been unbreakable, random keys used once and burned. But wartime production pressure led to key-page reuse. That single sin gave analysts something to grab. Mathematicians, linguists, and patient clerks ran pencil, paper, and early machines against fragments for years. They didn't read everything. They read enough. Code names emerged, antenna, liberal, rest, threads that later tied to Julius Rosenberg, his network, and Klaus Fuchs. Venona didn't print out guilt, it pointed. It whispered, "Look here," and investigators found the rest. Venona's power was also its trap. It was partial and slow. A cable from 1944 might yield a clue in 1948. Acting on it risked revealing that the West could read pieces of Soviet traffic, which would shut the window. So services moved obliquely, parallel investigations, human sources, and anonymous tips that protected the secret. Inside Langley and the FBI, a handful of people knew. Most didn't. That secrecy fueled paranoia, suspected moles, ruined careers, and years of internal suspicion. Still, the impact was real. Venona helped frame cases, steer interviews, and calibrate damage. It taught a habit: save everything. Your future self might understand it better. While historical clues from Venona crawled through translation, a live wound opened at sea. John Walker, a US Navy warrant officer with access to cryptographic material, walked into a Soviet embassy in 1967 and sold a key to the kingdom. The daily codes, key lists, and operating manuals that protected US Navy communications. He wasn't ideological. He wanted cash and validation. He recruited those closest to him, his son Michael, his brother Arthur, and a friend, Jerry Whitworth, turning family into a ring that lasted nearly 2 decades. Here, S.Y. Walker mattered. Crypto isn't just math, it's procedures. The Navy's KEYM-80, paper code sheets, rotor settings, and later electronic keying, flowed through communications centers worldwide. With access to those materials and the Chi-8/Chi-28/Chi-38 family procedures, the KGB could read portions of US Navy traffic in near real time when keys were compromised. Submarine positions, ASW tactics, convoy routes, even portions of nuclear release procedures. Surrounding admin chatter, suddenly Moscow had context. They didn't need every message. They needed enough to map patterns. When a carrier group went silent before flight ops, when boomers checked in at predictable intervals, when NATO exercises changed posture. Tradecraft kept the ring alive. Dead drops in parks and under bridges. A rural fence post with a loosened cap hiding film canisters. Packages wrapped in plastic, tucked in drain pipes collected at night. Prices were crude. Walker took thousands per delivery. Whitworth, a communications specialist, provided technical manuals and key lists for more. Family recruitment gave convenience and risk. It meant trust, until domestic fights and jealousy cracked the shell. It took an ex-wife's tip to the FBI in 1984 to unravel it. Even then, catching Walker required surveillance in parking lots, marked bills, and patience. When the arrests came in 1985, The relief tasted like fear, because nobody could count the damage cleanly. The consequences ran deep. Anti-submarine warfare tactics, carefully built around secrecy and acoustic advantage, suddenly looked transparent. If the Soviets could read portions of US traffic for years, then some of their evasions and boldness at sea made new sense. NATO communications procedures, message length, timing, and routing had to be rewritten. New keying devices were rushed into service. Training changed. You could swap hardware, but trust takes longer. Inside the Navy, whispers hung in air-conditioned spaces. What did they read? When? Who died because of a message someone else could read? Meanwhile, both sides kept upgrading the machines that wrapped their words. The Soviets ran FILKA cipher machines and bespoke systems for different ministries. The Americans moved from mechanical to electronic, KL7 to KG and KY families, pushing keys by paper, then tape, then electronic fill. The NSA hunted not just ciphers, but emissions. Tempest programs mapped how devices leaked information through electromagnetic stray signals and sound. Van crews parked outside embassies with antennas and oscilloscopes, pulling ghost signals from typewriters and monitors. Across the ocean, the KGB and GRU built their own versions, planting bugs in walls and furniture, vacuuming up RF noise, and smuggling in compromised equipment. Embassy floors became battlefields. In Moscow, US construction crews found listening devices embedded in prefabricated panels, so many that parts of the building were abandoned. In Washington, the Great Seal gifted to the American ambassador in 1945 contained a passive cavity resonator, the thing that sang secrets when a radio beam lit it. Engineers on both sides learned a new language: side channels, shielding, grounding. A loose cable could be treason. Venona's shadow complicated everything. The project's existence, still secret, fed mole hunts that spun out. James Angleton at the CIA followed threads until they strangled friendships and networks. Some moles were real. Aldrich Ames and later Robert Hansen would prove that. But in the 1960s and 70s, suspicion burned sources and paralyzed operations. The KGB watched the West flinch, then pressed harder where it hurt. Inside communications nodes, where one recruit multiplied into 1,000 compromised messages. Micro-stories keep the scale human. A Navy radio man on midwatch checked a safe twice, then a third time before closing it, unaware that a photocopier in a quiet office had already captured the week's keys. An NSA mathematician drew a lattice on a chalkboard and for a second saw a pattern collapse into meaning, then vanish. In a Moscow apartment, a KGB tech pressed a stethoscope against a wall, listening not for hearts, but for the click rhythm of a cipher machine's rotors, learning its personality like a song. The arms race inside signals shifted with silicon. As encryption moved to faster, more complex algorithms and electronic key distribution, the cost of a single traitor rose. Walker's ring thrived in the paper era. Its equivalent would be harder with electronic fill and frequent key changes, but not impossible if a human sat where the keys were loaded. That's the cruel balance. Technology raises walls, people keep doors. The lesson both sides pulled was brutal and simple. Never assume your channel is yours alone. Partition keys, rotate fast, monitor access like you monitor enemies, and treat the quiet clerks near machines as high-value terrain, because they are. While codes bled, the jet age was handing Moscow something else: metallurgy, radar waveforms, and the tools to strike what flew. The next thefts would teach pilots that the enemy sometimes knows your gear better than you do. The skies compromised: jet engines, radar, and SAMs. Air superiority feels clean from a distance. Sleek jets, contrails, perfect turns. Up close, it's metallurgy, heat, timing, and the right waveform at the right microsecond. During the Cold War, the KGB and its partners hunted those details. If you know the metal in a turbine blade or the pulse pattern in a radar, you can narrow gaps without flying a single test sortie. Start with engines. High-performance turbines live or die by materials science. The grain structure of single crystal blades, the chemistry of nickel-based superalloys, the way coatings handle hot corrosion. Western labs guarded that knowledge like crown jewels. Directorate tease lists flagged them anyway. Casting techniques, vacuum furnace parameters, directional solidification rigs, ceramic core recipes. Front companies ordered vacuum arc remelt furnaces. Student researchers asked odd questions at metallurgical conferences about creep rates at 1000 degrees Celsius. A photocopied process sheet that seemed dull, hold at X temperature for Y hours, cool at Z degrees per minute, turned into thrust margins on the other side of the world. Reverse engineering followed a familiar path. Acquire a Western engine, legally as a civilian variant or illicitly through a third-party teardown. Measure everything, cooling hole patterns in blades, diffuser geometry, combustor liner alloys. Then try to build it. The Soviet industry could match dimensions. Matching durability was harder. Without perfect alloy recipes and heat treatment curves, blades cracked early, performance sagged, and overhaul intervals shrank. So the hunt kept going for the step-by-step. How, not just the what. Each stolen furnace spec and coating schedule nudged the curve. Engines got more reliable. Range and payload tables in NATO binders quietly updated. While metal glowed, the ether filled with tricks. Radar isn't just range. It's a chess match between emitters and the countermeasures built to blind them. Western Air Forces fielded radars with agile pulses, low side lobe antennas, and frequency-hopping modes. They tuned electronic countermeasures to jam, deceive, and saturate. The Soviets wanted the recipes, transmitter characteristics, pulse repetition codes, receiver protection schemes, and they wanted the ECM handbooks that spelled out Western tactics. LineX targeted test ranges, contractor training centers, and maintenance depots, places where manuals were plentiful and vigilance was thin. The payoff showed up on screens. Soviet ground control intercept radars learned to filter jamming better, adding burn-through logic and track-while-scan modes tuned to known Western patterns. Engineers didn't need to guess at deceptive jamming if they had a captured pod's emission table. They could harden receivers against specific power levels and modulation types, tweak automatic gain control to ride out noise, and rewrite signal processors to recognize common false target schemes. In flight, a MiG pilot saw cleaner tracks when it mattered because someone in a safe house had copied a training slide years before. Then there were the missiles that waited for those tracks. Surface-to-air systems, the S-75 Divina SAR-2, S-125 Neva Pechora SAR-3, later the S-200 and S-300 families were more than rockets. They were radars, engagement procedures, and doctrine. Vietnam became a live laboratory. As SAR-2 started dropping American aircraft, US crews adapted. Jammers, chaff, new ingress altitudes, anti-radiation missiles. The KGB and the GRU vacuumed up everything, downed wreckage, pilot debrief rumors, and when they could, maintenance manuals for Western ECM pods and radar altimeters. Parameter theft translated into tactics. If you know the frequency agility window of a jammer, you can design a radar mode that sits just outside it, then hops in. If you learn a typical chaff cut length, you can adjust your clutter rejection to ignore that glint while still seeing a real target. Micro moments stitched these leaps. A Western avionics tech left a classified supplement on a bench during a lunch run. A visiting engineer memorized 2 pages on pulse Doppler notch filters. Weeks later, a Soviet radar lab ran a simulation against that filter, found the seam, and pushed a patch. That patch became a procedure. That procedure became a briefing in a regiment far from Moscow. The game spilled into factories. The Toshiba-Kongsberg scandal broke in the mid-1980 when investigators traced the sale of advanced multi-axis machine tools and computer-controlled milling systems to the Soviet Union, routed through layers of corporate fog. Those tools could cut propeller blades with precision previously out of reach, smoothing edges that used to sing like bells underwater. Quieter screws meant quieter submarines. Quieter submarines meant NATO sonar nets had to work harder and longer to get a fix. The fines and political fallout were loud. The hydrodynamic shift was quieter and lasted longer. Allied navies spent to adapt, retuning sonars, upgrading towed arrays, and rethinking patrol patterns. In the air defense belt, improvements compounded. Early warning radars widened coverage. Data links stitched batteries into networks. Fire control loops shaved seconds. A pilot flying into that web wasn't just meeting a missile. He was meeting a system that had trained against his last war's tricks. Western planners saw it in exercises and over Lebanon, where Soviet-advised networks learned to keep emitters dark until the last safe second, then surge power and angle for a shot. Even failures taught. A captured harm-seeker head offered insight into anti-radiation logic. That, in turn, drove decoy emitters and emitter shutdown drills on the Soviet side. Not every stolen edge was clean. Some imported specs carried the farewell-era poison. A radar software routine that looked efficient might degrade under certain clutter conditions, subtly blinding a sector when wind and terrain conspired. A coating recipe could leave a surface fine in lab humidity, but prone to micro-cracks in winter. Sorting sabotage from natural industrial noise took time and lives. Soviet engineers learned to second-guess perfect Western solutions, and Directorate T-built test cells to burn the lies out under stress before fielding. Human stakes threaded it all. A British engineer, proud of a new low-observable inlet treatment, talked too freely at a closed session. His note about surface prep, 20 minutes of solvent wipe before cure, seemed minor. It was the difference between flaking and adherence. In Leningrad, a turbine lab tech paid a modest bonus, stayed late to tweak a heat curve. Months later, a test cell ran 5 minutes longer before surge, enough to meet a spec. On a carrier deck, a pilot strapped in believing the jammer would save him. Somewhere, a handler flipped through a dog-eared manual that had taught the enemy how to wait it out. Impact landed on budgets and doctrine. Western Air Forces upgraded pods, rewrote tactics, and poured money into stealth as the only reliable way to reset the radar equation. That meant new alloys, complex shapes, and obsessive maintenance. Anti-radiation missiles grew smarter, memory-equipped, patient. Suppression of enemy air defenses turned from a supporting act into a campaign. Every increment the Soviets closed. An engine that didn't flame out, a radar that held track through noise, a SAM crew that knew when not to blink, forced another Western spend. Here's the quiet irony. The KGB helped build a Soviet air defense machine that was formidable by the late Cold War. It narrowed gaps just enough to be scary and expensive for the other side. But many of those advances rested on islands, good engines without a reliable supply chain of spares, sharp radars feeding into creaky command posts, brave crews working around factory floors. Parity showed up in photographs and sometimes on scopes. In the maintenance hangar, it frayed. Not that it soothed anyone flying the route. Pilots adapted to a world where the other side often knew their playbook because someone had read it. War turned on the smallest numbers, degrees, microns, microseconds. The KGB chased those numbers, and more often than not, found enough to matter. The result was a sky that felt tighter and a ledger that ran red for everyone. Not every triumph favored Moscow. Some wins contained their own poison, and not every edge could be stolen. The next moves would come from inside Langley's vaults and Moscow's distrust. Deception, doubles, and a hunt for ghosts inside the very services running the game. The CIA's counterplay, deception, double agents, and moles. Turn the tap off or feed it poison, that was the choice. After Farewell exposed LineX's plumbing, Langley and its allies faced a hard truth. They couldn't close every valve, so they learned to tint the water. Deception started in boardrooms and basements. Engineers sat with case officers and drew 2 sets of drawings, one for honest buyers, one for thieves. A CAD file would match dimensions, but hide a tolerance stack that caused a rare, catastrophic resonance. Firmware would pass diagnostics, then hiccup under field load. Documentation would omit a single shim or key step, causing subtle drift. Industry called it versioning. The CIA called it active measures in reverse, Maskirovka for engineers. To make it work, they needed channels. Double agents turned those channels into stagecraft. Some were genuine penetrations of LineX, assets inside residentiaries who could steer collection to the bait. Others were Western officers and engineers pretending to be sources, feeding near truths that tracked close enough to be believed. The art was calibration. If you poison everything, your enemy learns to ignore the buffet. If you salt only a little, the good bites carry the bad. Case officers rehearsed near-truths with their sources until the lies felt lived in. Tradecraft wrapped around the theater. A courier took delivery of a manual in a hotel bar and was nudged, quietly, toward the flawed copy. A brush pass at a trade fair delivered a real component and a compromised firmware pack, knowing the lab would merge them. Backstopping mattered. The bait needed provenance. So export control offices wrote plausible license trails for devices that were meant to be stolen. Warehouse logs matched serials. Test benches showed where. If a KGB tech sniffed too hard, he'd still smell factory. Meanwhile, mole hunts inside Western services chewed time and trust. James Angleton's long shadow lingered, friendships frayed, networks froze. But after 1981, the focus sharpened. The question wasn't just, who's the mole? It was, what do we let him see? Compartmentation increased. Analysts got need-to-know slices. Stores of keys and code word programs moved to stricter vaults. And counterintelligence teams ran canaries, unique data markers planted in separate compartments to see which stream leaked where. When identical phrases appeared in hostile reporting, a door slammed and a life sometimes changed forever. Here, where it cut deep. Feeding LineX risked real people. A double agent who passed doctored specs still had to look like a thief in the eyes of his KGB handler. That meant delivering occasional genuine value. Lives rode that balance. Some assets broke under the strain. Some filled their envelopes with real gold because they couldn't face the suspicion that came with sand. Case officers wrote letters to families after those choices collapsed. Careers ended in quiet offices when a line went dark. The CIA also staged long-fuse failures. A turbine control algorithm seeded with a rare edge case. A numerical control post-processor that introduced micrometer-scale bias after 1,000 cycles. A software library that leaked precision in the 8th decimal place only under Arctic temperatures. These weren't dramatic explosions. They were reliability sinkholes. A system would pass tests, field well, and then at the edge, fail just enough to force costly rebuilds. Directorate T learned to run burn-in tests and environmental chambers because the West forced them to. Parallel to deception, double agents offered insight that saved lives. Some sat inside LineX and reported tasking priorities, which chips, which tour, which companies. That visibility let Western services harden specific nodes instead of spreading paranoia everywhere. Others sat inside the KGB's counterintelligence arms and warned when a source was under review. Exfiltration plans, staged identities, clean phones, cash, sat folded in desk drawers. Sometimes they worked. Sometimes they arrived 2 days late. Langley also ran theater. A compromised front company in Europe would sell mid-tier machine tools to an Eastern Bloc buyer under the soft eye of a Western service. The tools shipped with flawless paperwork and hidden weaknesses. A tech team followed the packages with ears and cameras, mapping the eastern end of the pipeline, warehouses, customs officials, technicians. That map fed future arrests and future bait. The operation looked like commerce. It felt like chess. All this happened while real moles gnawed at the CIA from within. The distrust wasn't paranoia alone. It had cause. The risk sharpened the tradecraft. Fewer people knew full operations. Case officers met assets in smaller circles. Reports into analysts carried caveats and origin masks. It made operations safer and analysis harder. A half-truth shaped by deception could look a lot like a real truth shaded by humans' normal mess. Politburo briefers weren't the only ones who wrestled with analytic noise. The West drank from its own fog when it had to. Micro-stories bear the nerve damage. A case officer in a suburban diner slid a white envelope across a red Formica table, knowing it held a document engineered to fail in 2 years. He didn't sleep for 3 nights. A Soviet handler read a near-perfect machine manual and felt pride. His source delivered. Months later, a field mishap made him suspicious of everyone, including himself. In a Silicon Valley conference room, an engineer argued with his manager about whether to cooperate with the government on a security initiative. He said yes. He went home and didn't tell his wife why. The political layer pressed too. Deception programs needed legal cover and executive sign-off. Export control coordination meant diplomats asked allies to tolerate sting operations that could splash into domestic politics. When friendly firms got caught in the web, unwittingly feeding LineX or selling to shady fronts, governments had to choose between prosecution and quiet fixes. Some took the headline. Others took the phone call. The ledger of favors got long. Did the strategy work? It slowed, it redirected, it confused. Soviet labs spent time chasing ghosts. Directorate built verification pipelines that ate resources. KGB handlers grew cautious, sometimes rejecting real gold because it smelled too clean. Moscow analysts, faced with a mix of true and tainted, made conservative calls that dulled edge cases. On the Western side, disinformation blurred some of the KGB's sharpest victories and bought months and sometimes years. Not everything could be faked, much could be fogged. Then the ground shifted. The 198s bled into uncertainty. Afghanistan consumed budgets and confidence. Oil prices played havoc. The center cracked, ideology fatigued, shelves thinned. Arrests and defections hit both sides. Some of the CIA's deepest secrets leaked to Moscow, and some of Moscow's habits leaked to the world. Deception could sting, but it couldn't solder a broken circuit inside a state. As the system strained, espionage looked like a tourniquet on a deeper wound. Yet the ledger wasn't one-sided. Western programs took hits that never made headlines. Operations were blown. Assets died. Upgrades came early and expensive because someone somewhere had read the manual meant for tomorrow. The quiet cost ran real, and it set up the last question this story has to ask. If theft bought time for Moscow, could it buy survival against gravity? The fall, how espionage couldn't save a breaking state. The question hovered over every sealed briefcase in Moscow. Could stolen brilliance outrun the weight of a system that couldn't feed itself? Directorate kept delivering trophies, chips, manuals, algorithms, but the factory floors that had to turn those prizes into fleets and brigades were seized by habits that espionage couldn't fix. Planning targets beat physics. Quotas beat quality. Managers lied up the chain because truth ruined careers. Theft bought time. It didn't buy competence. Start where machines meet people. A Western CNC control arrived through a front company. Real capability, real potential. The Soviet plant installed it, then fed it with dull tools and misaligned fixtures because the toolroom hit its quota by counting units, not tolerances. Chips piled hot and blue. The new process worked one day and drifted the next. Engineers wrote memos, managers filed them. The manual's page on preventive maintenance got ignored because maintenance wasn't in the plan. Espionage delivered how. The plan demanded how much. Innovation starved inside the 5-year rhythm. Institutes modeled, ministries ordered, factories complied. Feedback moved like winter traffic, slow, grinding, never direct. A lab that discovered a fix for a vibration problem couldn't push it to production without permission slips across ministries. Meanwhile, the defense calendar screamed. Copying kept pace with last year, integrating lagged this year and next. Western gear changed annually. The Soviet copy entered a system that treated change like a personal insult. Afghanistan bled cash and belief. Tanks that looked fine on parade fought mountains and mud until seals failed and transmissions burned out. Helicopters needed spares. Spares needed factories that already missed deadlines. The war consumed fuel, ammunition, and illusions about easy wars against bandits. Each conv needed protection. Each replacement needed a budget carve-out that didn't exist. Espionage couldn't conjure harder steel or motivated conscripts. It couldn't refill a ration depot or soften the news of another ambush. Then the atom bit back at home. Chernobyl wasn't born from ignorance alone. It was born from a managerial habit that told operators to run a test at night under rules that looked tidy on the page and hid risk in the margins. When the reactor blew, the state's instinct was secrecy and sacrifice. The blast exposed more than a reactor design flaw. It exposed a culture that gamed safety and punished candor. Western services watched the plumes and understood something basic. A system that can't admit small failures breeds large ones. No microdot fixes that. Budget strain turned technical debt lethal. Oil prices fell. Hard currency tightened. The Warsaw Pact's economies dragged. Importing Western machine tools and test gear got harder just as the need for them got sharper. Directorate T kept the pipeline open, but validation labs needed spare parts and power that arrived late. Burn-in tests ended early because management needed a success on a chart. A poisoned firmware routine planted by Langley might fail in 2 years. A rushed production run failed next week on its own. Tests and defections ripped muscle from the KGB and from Western services alike, but inside Moscow, they landed in a brittle body. Vitaly Yushchenko's sensational defection to the US in 1985, followed by his redefection back to the USSR, threw acid on trust. Was he a plant or a man who broke? Either way, case officers eyed their own phones like snakes. Around the same time, Western moles inside Soviet services, fed by years of careful work, started to pay off. Lines went dark. Handlers rotated. Some illegals cut contact and lived half-lives in place. The paranoia that Angleton had baked into CIA culture found a mirror in Moscow's corridors. Tradecraft deteriorated at the edges because the center couldn't hold standards. Training shortened. Budgets cut travel. Younger officers, raised on stories of triumph, found a field where sources wanted cash the state didn't have and where front companies closed when bankers called notes. A handler who once managed 3 sources with precision now juggled 8 with guesswork. Mistakes multiplied. One missed signal became a blown meet, became a surveillance tail, became an arrest. Some of those arrests carried Western fingerprints, double agents warning just in time. Others carried paperwork scars, sloppy legend files, mismatched cover stories, a stamp in a passport that didn't match the supposed itinerary. The espionage paradox sharpened. Copying replaced discovery. Doctrine that should have evolved around new capabilities froze around what could be replicated quickly. Engineers learned to write just enough originality to pass review and then reach for a Western binder. That kept programs moving, but it hollowed the muscle that invents. The culture that punished failure punished novelty harder. The safest career path was to deliver a familiar result late and claim complete success. The Politburo heard progress. Regiments received equipment that needed field fixes the manuals didn't mention. NATO planners watched the contradictions pile up. On paper, Soviet radar nets thickened and missiles tightened their set. In exercises and intel, analysts saw maintenance shortcuts, parts cannibalization, and commanders improvising around shortages. A factory could build a batch of precision gyros with great results, then stumble when a shipment of epoxy changed characteristics, and no one dared halt the line. Western disinformation aggravated some of it, but much of the drag belonged to the system itself. Micro-stories made the rot personal. In a Leningrad plant, a machinist painted a gauge needle higher because he needed to get home for his daughter's recital, and the foreman wanted green ink. In a closed research institute, a young programmer proposed a new scheduler for a real-time OS. His boss told him to translate a Western paper instead. In a GRU office, a colonel signed a travel form he knew was fiction because the mission mattered and the bureaucracy didn't. Each choice made sense locally. Together, they dulled the spear. Politics shifted and pulled the rug. Glasnost and perestroika opened windows that let in light and wind. Transparency exposed theft not as triumph, but as dependence. Economic reforms revealed balance sheets that couldn't hide military overreach. The Soviet Union needed hard currency, food imports, and peace more than it needed a new variant of a copied computer. The KGB's finest technology thefts earned presentations in rooms where the real agenda was debt, bread, and border states eyeing exits. When the Warsaw Pact cracked and the flag came down, the files didn't vanish. They sat in cabinets and in heads, proof of an intelligence machine that ran well even as the state that fed it stumbled. That's the last bitterness for the officers who worked those lines. They did their jobs, often brilliantly, often at real personal cost, and still watched regiments break under logistics and politics. They stole the West's future in pieces and found that the present at home kept breaking. Espionage bought performance where it could and delay where it had to. It forced the West to spend and to think harder. It won increments, radar ranges, engine hours, software tricks. But it couldn't fix a ledger, feed a factory, or teach a bureaucracy to reward truth. In the end, the breaking state made promises the stolen blueprints couldn't keep. Yet the bill for the West was real. Operations exposed, programs rushed, money burned. The ledger would need its own chapter. What was lost? Western vulnerabilities and the quiet costs. The ledger wasn't one-sided. While Moscow's system strained, the West paid in silence. Operations compromised, programs rushed, and lives bent around secrets they didn't know were already gone. Start with what hurts most in war. Trust in your own kit and your own channels. For years, Western commanders made calls on networks the KGB could sometimes read, plan around radars the KGB had studied, and deploy tactics the KGB had rehearsed against with stolen manuals. No briefing slide captured the anxiety of that reality. Flight crews just called it gut check. Naval communications took the deepest cuts. When the Walker Ring fed keying material into KGB hands, portions of US fleet traffic leaked for years. That meant Soviet analysts learned rhythms, check-ins, patrol cycles, exercise patterns. Even after the arrests, damage assessments dragged. NATO changed procedures and rushed new crypto gear, but confidence needed time that operations didn't grant. Quietly, planners revised assumptions. The enemy might not just guess your route, they might know enough to wait. Convoys grew more conservative. Submarines adjusted reporting tempos. Every change cost fuel, hours, and flexibility. Air operations paid too. Each stolen ECM supplement, each radar emission table lifted from a depot or contractor had a downstream cost. Crews flew jammers that the other side had modeled. Tactics that once could surprise now had to be layered and sequenced with more caution. The effect wasn't visible in headlines. It showed in timelines. Longer suppression windows, extra sorties, more tanker demand. An air wing can do that for a month. A war asks for months. Industrial controls hid another bill. Power systems, pipelines, and factory automation relied on vendors and integrators spread across continents. Directorate T mapped those networks to spot where military and civilian tech overlapped. Theft of SCADA protocols and vendor maintenance packs meant the Soviets could understand, and sometimes anticipate, the shape of Western infrastructure resilience. It also meant the West lost its monopoly on recovering fast from sabotage. When the pipeline poison pill idea surfaced, it came with a mirror. If you concede flaws there, they concede flaws here. Engineers lost sleep over firmware they didn't write, running on machines they didn't truly own. Diplomatic cables carried the human side of vulnerability. Embassy bugs, compromised cipher machines, and penetrated code rooms meant ambassadors sometimes negotiated through a veil the other side could lift. That shaped tone and timing. If you suspect your message is read, you write differently. You hedge. Allies sense the hedging and grow careful themselves. Trust thins across a table nobody sees. The public hears a bland press conference. The private cost is a missed chance to speak plainly when it could have mattered. Economically, the West paid twice, once to invent and again to leapfrog what it feared was already compromised. R&D duplication became a quiet tax. Programs accelerated not just for capability, but to outpace theft. A radar upgrade scheduled for 3 years out moved to 18 months. That pulls engineers from other projects, raises error rates, and bloats budgets. Export control tightened, dragging companies into compliance regimes that slowed legitimate trade and seeded resentment in sectors that weren't used to security clearance logic. Small firms, the ones who make odd parts and clever software, struggled under audits and paperwork. Some stopped selling abroad. Some left defense work altogether. The human ledger is heavier. Assets recruited inside the Soviet system were exposed by betrayals Western services didn't see coming. Aldrich Ames and later Robert Hansen weren't in this story by name yet, but their shadows fell across it. Sources went silent, then to prison, then to grave. Case officers carried those names like stones. On the other side, Western engineers and technicians who thought they were sharing harmless details found themselves under investigation, or in court, or cut off from careers. A family's mortgage can hang on whether a drawing in a briefcase crossed a line someone else drew late. Careers shattered inside services too. Mole hunts don't just catch moles, they eat confidence. Teams that should have been running operations ran internal checks. Analysts who needed context got fragments with origin labels blacked out. That made bad calls likelier and brave calls rarer. Some officers never recovered their footing after false suspicion. Others did their best work under surveillance they could feel, not see. That drag isn't a budget item, but it empties a room of risk-takers when you need them. Programs took direct hits. Naval quieting schedules shifted because Toshiba-Kongsberg's fallout forced retuning. Suites iterated faster to answer Soviet adaptations. Satellite programs hardened against ground compromise. More secure uplinks, tighter keys, walled-off contractor teams. All necessary, all costly. When a project manager has to choose between capability and security timeline, he learns quickly that the wrong choice can kill people. He also learns the right choice can stall a fleet. Strategic misreads piled in the gaps between stolen snippets and leaked poison. Western analysts sometimes overestimated Soviet integration because the specs looked good on paper. That led to conservative planning, which is safer in war and expensive in peace. Other times, disinformation fed to LineX boomeranged. When Soviet reports reflected bait the West had planted, both sides drowned in analytic noise. Politicians asked for clarity. Intelligence chiefs delivered ranges and caveats. The cost was political capital, trust between elected officials and the people who brief them. That trust is a weapon too, and it dulled. Look at micro moments. A Royal Navy officer walked into a comms shack at dawn and found a safe open, a junior rating asleep, the week's keying list folded wrong. No breach, just fallible humans, and a reminder that the hole is always where the habit lives. A West German engineer took a call from a trade consultant, and for a minute thought about his student loans before hanging up and calling security. He spent the next year watching his colleagues wonder if he'd been the leak. An American attaché in a European capital typed a cable on a machine he didn't fully trust, softened a phrase, and carried that regret for 20 years. Allies bore quiet costs too. Expulsions after farewell hit European capitals hardest. Trade shows tightened badges and lost deals. Small countries felt caught between Washington's pressure and Moscow's charm. Some bristled at being told their export reviews were weak. Some knew it was true and lacked resources to change fast. The KGB exploited that space, widening cracks with polite invitations and cash. Culture took a bruise. In Silicon Valley and other tech hubs, cooperation with government turned from Cold War duty into an argument. Engineers asked why they should carry security burdens for a risk they didn't create. Some stepped up. Others opted out, and capability bled sideways into sectors with less oversight. The downstream effect. More blind spots, more vendor sprawl, more places where a front company could hide. The lesson that emerged scared everyone who understood it. Security isn't a product you buy after design freeze. It's a culture you build into every hire, every protocol, every meeting. The West learned that late in too many corners. It paid in duplicate work, in mistrust, in money poured into vaults and guards instead of pure invention. And it paid in humility, the knowledge that the other side's quiet system had reached farther and sooner than most had admitted. So what was the KGB's real secret weapon? Not a camera or a code or a bug in a seal. It was the system itself, disciplined, patient, human-scaled, turning overlooked hands into levers. The secret weapon defined, system over gadget. Here's the reveal. The KGB's edge wasn't a miracle device. It was a disciplined production line for secrets. LineX set the shopping lists. Directorate T validated and integrated. Illegals and recruited insiders did the lifting. Case officers managed the flow like logistics managers. Think supply chain, not smash and grab, acquisition, validation, integration, protection. Culture made it work. Recruit early, wait years, harvest for decades. A student became a code clerk. A clerk became a system admin. An admin became the switchboard for a whole command. The KGB invested in trajectories, not trophies. Patience turned one shaky cufflink into 1,000 pages over time, each linked to the next operation like gears. Targets weren't just ministers. They were the overlooked hands at the switch, clerks, coders, technicians, repair crews, trainers. Those people saw the messy truth, how procedures actually ran, where tolerances slipped, which shortcuts crews took. A technician's maintenance note could be worth more than a general's speech. Human targeting found the gap between paper and practice, then lived there. Tradecraft tied the chain together. Cutouts and brush passes kept sources compartmented. Microdots, pouches, and dead drops kept material flowing with minimal exposure. Validation teams cross-checked a drawing against a signal intercept, then against a purchase order. If 3 streams aligned, the product moved to integration. A Soviet lab reproduced it, stress-tested it, and wrote doctrine around it. If the stream smelled salted, it went to burn-in labs and environmental rigs before fielding. Feedback closed the loop. Stolen tech didn't just fill shelves, it guided R&D priorities. A captured firmware routine nudged a guidance algorithm roadmap. A radar training slide altered a processor procurement plan. Results fed back into targeting. If a lab failed at a step, LineX hunted the missing recipe. The system learned in cycles: steal, test, field, adjust, retask. Risk management sat at every stage. If a source flashed hot, lines went dark and stayed dark. If a handler went cold, a new legend took over the route. After farewell, verification hardened, long-duration tests, redundancy, parallel shops to spot sabotage. Losses hurt but didn't halt. The machine flexed and rerouted, keeping throughput steady. That's the secret weapon, an invisible factory. Not an invention, a process that turned access into advantage and leaks into ladders. Even after the flag came down, the habits didn't vanish. They adapted to fiber, firmware, and cloud keys. The same patient cadence, new pipes. Epilogue echoes today, from cyber to corporate. The habits didn't die, they updated. Today, the pipeline runs through code repositories, vendor portals, cloud consoles, and supply chains so dense that nobody sees all the links. The stakes are the same. Who controls the keys? Who sets the clock? Who turns the lights off when it counts? Start with supply chains. Modern defense programs live on commercial chips and outsourced firmware. A single baseboard management controller on a server in a data center can hold credentials that open doors from logistics to targeting models. That overlooked hand at the switch is now a third-party contractor with admin rights to a ticketing system, or a junior DevOps engineer who can spin up instances with privileges nobody audited. The KGB's old patience fits perfectly here. Map vendors, profile admins, recruit the one whose LinkedIn shows late-night rants about being ignored. Cyber units replaced many of yesterday's residentiaries. Phishing kits are the new brush passes. Living off-the-land techniques are the new dead drops. A spearfish that lands on a contractor's laptop can lift VPN tokens, jump into a continuous integration server, and slide a subtle change into a library that dozens of defense suppliers use. No fireworks, just a bug that lowers entropy in a random number generator or weakens signature checks in a firmware update. The theft isn't a file, it's a future failure scheduled. Talent poaching blends with espionage. Venture capital with opaque limited partners funds startups near the edge of dual-use tech, drones, autonomy, sensors, quantum timing. Advisory deals and research partnerships come with innocuous NDAs and quiet obligations. The asset doesn't think he's an asset. He's a consultant, paid to de-risk operations in a foreign market, while writing memos that map his company's strengths and blind spots. A year later, a rival in a friendly capital launches a product that seems uncannily calibrated against his roadmap. LineX's spirit lives in front companies that look like cloud resellers, logistics integrators, and testing labs. Hardware moves through free trade zones. Code moves through open-source ecosystems where maintainers are underpaid and overworked. A pull request that fixes a rare race condition buys trust. The next pull request turns a debug log into a credential leak that only triggers under load. It's not sabotage, unless someone bothers to look when the outage hits, and most teams blame themselves first. Continuities are blunt, patience still wins, proxies still shield. Trade shows turned into security conferences and developer summits where hallway chats swap as much value as any keynote. Differences are merciless. Speed compresses everything. A zero-day exploit burns bright for days, not months. Cloud misconfigurations replicate at machine speed across hundreds of accounts. Data isn't a drawer of files. It's petabytes of telemetry, models, and training sets that teach missiles to see and pilots to survive. Steal a model, and you steal a decade of experience distilled into weights. Western blind spots multiply with convenience. Vendor sprawl means a program that used to have 20 dependencies now has 2,000. Shadow IT grows from one team trying a new tool without security sign-off. Boards ask for risk dashboards. CISOs give them colors and caveats. Meanwhile, procurement departments squeeze on price and speed, selecting vendors that promise delivery tomorrow with near-identical capability. That phrase should chill everyone who remembers how near-truths worked. Micro-stories bridge eras. A help desk tech, proud of solving tickets fast, resets a password for a traveling executive after a convincing voice call. That single MFA bypass opens a mail archive that contains a spreadsheet of API keys. Across town, a graduate researcher shares pre-trained weights with a collaborator for a joint paper. A clause in the collaboration agreement lets the other lab reuse derivatives freely. 6 months later, a drone over a desert behaves like it learned from that model. In a suburban office park, a firmware engineer accepts a LinkedIn message offering a fee for reviewing a generic bootloader. She returns comments, paid via a crypto wallet. 2 versions later, the bootloader shows up in an overseas router with a curious debug path intact. Governments respond, but unevenly. Export controls morph into lists of emerging and foundational technologies, while regulators chase yesterday's definitions. Cloud sovereignty rules collide with multinational project realities. Lawmakers demand supply chain transparency. Integrators present diagrams that are accurate and incomplete at the same time. Intelligence services seed deception again. Fake datasets, canary tokens, telemetry that fingerprints thieves. But deception is harder when stolen code runs in the thief's own cloud and never touches a border post. Allies strain under the old pressures in new clothes. A startup in one country lands a defense contract in another, then finds its largest investor tied to a fund in a jurisdiction with active collection priorities. Do they divest? Do they firewall the investor? Who pays for the lost runway? Meanwhile, public-private cooperation hinges on trust that sours fast if companies feel exposed in headlines after quiet cooperation. The fix requires culture, not memos. Security built into sprint planning, vendors audited as rigorously as primes, red teams granted room to break things before adversaries do. The takeaway is uncomfortable but clear. History's playbook didn't retire, it pushed a software update. The same system logic: recruit trajectories, target access nodes, validate, integrate, protect, runs in a world where access nodes are API gateways and trajectories are careers that move from grad lab to unicorn to defense prime in 5 years. The answer isn't nostalgia for higher fences. It's discipline, keys rotated and scoped, logs kept and read, dependencies mapped and minimized, people trained to see the flattery that comes with a hook. One last thought before we close. The question that started in a burning flat in Vienna still hangs over bright server rooms and quiet kitchens where laptops glow at 2 a.m. when the moment comes. A link clicked, a call answered, a file shared. Does the system you live in make the easy choice the safe one? Or does it wait for a culture you don't have to save you from a habit you haven't changed? Resolution and broader meaning. Espionage didn't win the Cold War, but it rewired it. That wiring still runs through our factories, clouds, and habits. If this story raised your guard, there's more. Subscribe and don't miss our next chapter on today's tech theft pipelines, from venture deals to firmware backdoors. And if you want to see how these lessons collide with the battlefield, watch the deep dive on the F-35 versus drone swarms linked here. What's already in the wrong hands?